So AI agents are getting insanely powerful, right? We're talking about a world where they can connect to, literally thousands of different tools and services to get stuff done for you. But here's the thing. As we try to scale this up, there's this huge hidden problem that pops up and can just grind everything to a halt. So let's dig into what that bottleneck is and then talk about a really, really cool solution.
Think about it. Thanks to these new open standards, a developer can build an agent that has access to this entire ecosystem of tools. We're not just talking about a couple of things. We're talking hundreds, maybe even thousands of tools. Everything from your Google Drive to Salesforce to whatever else you use. All of it available to one single agent. The potential is, well, it's just staggering.
But, of course, there's always a catch, right? So what actually happens when you give an agent access to 1,000 tools? Do you just get something 1,000 times more powerful? Well, not exactly. Turns out there's a hidden cost, a pretty nasty bottleneck that can make these would-be super agents surprisingly slow and clunky.
Okay, so let's put a name to this problem. It's what we call the agent's scaling problem. And the tricky part is, it's not some random bug. It's actually built into the very design of how most agents work today.
And every good story needs a villain, right? Well, the villain of our story is something called token overload. Now, if you're not familiar, just think of tokens as the currency of an AI model. They're like little pieces of words that the AI reads. Every single thing, every instruction, every tool description, all the data, it all gets chopped up into tokens. And just like a real budget, you only have so many tokens to spend, and they can get really expensive fast. So where does this token overload come from? Well, it happens in two big ways. First off, just for the agent to know what tools it even has, it has to load up all of their definitions and descriptions into its working memory, what we call the context window, right at the very beginning. And then, here's the real kicker. Every single time it uses a tool, the result from that tool has to be passed all the way back through the model, just so it can figure out what to do next.
Okay, let's make this super concrete. Imagine you ask your agent to do something simple. Hey, take this meeting transcript from my Google Drive and add it as a note to a contact in Salesforce. Sounds easy, right? Well, with the standard approach, what we call direct tool calling, the agent first calls Google Drive and grabs the entire transcript. Let's say that transcript is huge, maybe 50,000 tokens worth of text. That entire thing gets crammed into the agent's context. But then, to call Salesforce, the model has to spit that entire 50,000 token transcript back out again as part of the new tool call. It's literally reading and then writing the exact same massive block of text just to move it from point A to point B. It's just incredibly wasteful.
Yeah, you can see how that's just not going to scale. But what if the agent didn't have to work like a clumsy switchboard operator, manually plugging and unplugging data? What if it could act more like a software developer? And that brings us to a much, much smarter solution, using code as the engine. This whole approach is called code execution, and the idea is actually pretty simple. Instead of the AI model calling the tools itself, it just writes a little snippet of code to do the job. So the key insight here, the most important part, is that all the heavy lifting, moving that big transcript around all the logic, it all happens in a totally separate place, completely outside of the model's limited and very precious context window. And check this out. This is what it looks like in practice. For that exact same task, the agent doesn't pass data back and forth. It just writes this simple bit of code. See? It calls Google Drive, puts the content into a variable called transcript, and then it passes that variable straight to the Salesforce function. The giant wall of text from the transcript, it never once touches the model's context. It just flows from one service to the other, all handled by the code.
So you might be wondering, what's the actual difference here? Is this just a small tweak? No way. The impact is absolutely massive. Let's look at the numbers. Look at this comparison. It's just night and day. For a complex task with big documents, the old direct calling method could easily burn through, say, 150,000 tokens. But with code execution, the agent only uses about 2,000 tokens. That's because the model only has to see the small piece of code, not all the huge amounts of data being passed around behind the scenes. Yeah, you're seeing that right. That is a 98.7% reduction in token usage. Just let that sink in for a second. This isn't just about making things a little cheaper or a little faster. This literally unlocks the ability to do tasks that were flat out impossible before, because they would have just blown past the model's context limit. It is a total game changer. And believe it or not, it gets even better, because this isn't just about being more efficient. Giving an agent the power to write its own code, well, that unlocks a whole new set of superpowers.
Okay, check this out. Now, an agent can load only the tools it needs, right when it needs them. No more loading everything up front. It can filter and mess with huge amounts of data before that data ever gets near the model. It can use real programming logic, we're talking loops and if-then statements. It can work with sensitive private data without the LLM ever seeing it. And this might be the coolest part. It can save its own code to build a library of reusable skills.
Here's a perfect way to think about it. Imagine you need to find just 5 customer orders from a giant spreadsheet with 10,000 rows. The old, clunky way? You'd have to feed all 10,000 rows to the AI, just flood its context. The new way? The agent just writes a quick line of code to filter the data, and the model only ever sees the 5 rows it actually needs. Simple, efficient, smart.
Or how about something with a bit more logic? Let's say you want the agent to monitor a Slack channel and wait for a specific message, like deployment complete. Doing that with direct tool calls is a total pain. It's this messy loop of call Slack, check the result, wait, call Slack again, and every single step goes through the model. With code, the agent just writes a simple while loop that hums away quietly and efficiently in the background. It's just clean.
And that brings us to what might be the most mind-blowing idea of all. This concept of skills. Think about it. When an agent figures out a useful piece of code to solve a problem, it can just save it as a reusable function. So the next time it faces that same problem, it doesn't have to reinvent the wheel. It just calls on its own saved skill. Over time, the agent is literally building its own custom toolbox. It's learning. It's evolving.
So let's zoom out. What does all of this mean for the future? Where are these smart agents actually heading? You know, one of the key takeaways here is that even though these AI problems feel super new and cutting edge, they're actually not. At their core, these are problems of managing data and state and making tools work together. These are the exact kinds of challenges that software engineers have been figuring out for decades. So code execution isn't some crazy new magic trick. It's really just about taking these tried and true engineering principles and applying them to AI agents. Now, it's only fair to mention there is a catch. You can't just let an AI write and run code on your system willy-nilly, right? That would be a security nightmare. So this whole approach requires a secure, lockdown sandbox environment where the code can run safely. That does add a bit of complexity to set up, for sure. But for most serious applications, the massive gains in power and efficiency are more than worth that extra step. And all of this leaves us with a pretty wild question to think about. When an agent can do more than just use tools, when it can actually write, save, and reuse its own code to build entirely new abilities from scratch, at what point does it stop being just an assistant? You have to wonder, are we watching the very first steps of AI agents becoming, well, autonomous developers?